worksheet, the one that says coloring key features. So looking at number 1, we need to find the first 3 attributes in order to graph it. So pull out your calculators. Type in the function. You just go y equals x squared minus 3x minus 4. Push graph. So if you don't have the correct, hey, Travis, Zach, which one of you wants a front row seat? Okay, Aubrey will switch with whichever one of you is noisier today. So if your calculator doesn't have the right window, push zoom 6. Is anybody having trouble graphing it? All right. So we're just going to go through a couple things to remind us how the calculator works. Zach, do you have a calculator? Oh my goodness. Well, that's okay. It's not my grade. So, okay. How can I guarantee that those roots are the easy numbers that they look like? Okay, zooming in is a waste of your time. Okay, never, ever, ever, ever use trace. Okay? Because trace will get close, but it will never be perfect. I don't know. You could guess. How would you guess? Okay, so let me show you a super easy tool that's going to come in handy this year. You ready? Zach, if you think you need to open your mouth, don't. Okay? So, second table. It's on the graph button. So this will give us a bunch of x's and y's. Is one of the roots actually -1? Yeah, how can you tell? It's -1 comma 0. Okay? So one of the x-intercepts is -1. If I go down, can I find the other one? Oh, is your table set messed up? Well, you just need to go up and down. Your tables. So if your tables are going by funny numbers, push second table set, and your delta, that little triangle is called delta. Table set's right there. Change your table, your change in table to 1, and then make sure that the others are on auto. And that should fix your table. Now just push second table. So you can go up and down in the table as much as you want. Is my second root 4? Yes. Now, what if they're not those? How can we find the decimal? I heard somebody saying it earlier. Second calc, 0. Number 2. Okay? Now, we know what the roots are, but I want to practice because you're going to be doing this a lot in this class, finding values on graphs using this. The calculator is going to ask you 3 questions. Left bound, right bound, guess. Now, anytime you do left bound, right bound, guess, you're always using x values. So basically what's happening, we have this graph. The calculator wants you to create a tunnel of x's to find the root. Okay, so it wants if you want this point, you need to pick some number to the left and some number to the right. Would it make sense to do those numbers? If your guess is close enough, the calculator won't be too mad at you. But you want to exclude the other root. Okay? So what would be a good left bound? Negative anything further than 2 would work. So I'll do -5. What would be a good right bound? 0, 1, 2, 3. I wouldn't want to go beyond 4. And my guess will be -1, and it is in fact -1. Okay, and we looked at the table and we figured out that my x-intercept is -4. Okay. Oh, it's just regular. It's just Danny 4. Vanilla ice cream Danny 4. Okay. It did. When your love handle gets stuck on one of these, that doesn't feel good. And for those of you at home, we're not going to tell you what just happened. Okay. We used to leave messages in the sophomore class last year. Or I mean in the junior class last year, we'd leave messages for people who were gone that we knew would watch the video. And you didn't even check it. Oh. Man. Okay. That's what happens. Sure. Okay. Y-intercepts. What is the y-intercept? How do we know it's -4? We could go to the table and look at x equals 0 and it says y equals -4. Or we could plug 0 into the equation. Or just look, this in a polynomial, that will always be your intercept. So y-intercept is -4. And then we need to find, it says maximum. It should say maximum or min. So y equals -4. How do we find the minimum? Second calc. Well, this is minimum point. We want to know both the x and the y. So what's a good left bound for the minimum? So you can hit, did you guys know that you could do this? You can move that cursor. Yeah. So you can use the cursor or you can just type in numbers. So 0, right bound maybe 4. My guess will be 1. And my minimum point, and this is the calculator attempting to be smart, and it's not. So it really is 1.5 comma -6.25. It just it rounds. It rounded off that. Well, it uses a complicated equation to figure it out, and it just does. Okay, now that I have those 4 pieces of information, I can graph it. So one root's -1. My y-intercept is -4. My minimum is going to be right here. And I have a root at 4. That's my graph. Any questions about that? Max or min, depending on the direction of the parabola. Yeah, I updated that on the website. It'll be correct. Jason, you all right? You need glasses? Okay. Do you guys remember domain and range? Domain would be all of the x's that are represented on the graph. Are there any x's that miss the graph? So what about -10? Does -10 show up on the graph? Where? Way up high. Okay, what about 2? Does 2 show up on the graph? Yeah, right there. What about positive 10? Yes, and in fact, as long as it's a polynomial, like linear, quadratic, cubic, anything like that, it will always be all real numbers. The only time you'll have a function that is not all real numbers is when you break the rules of real numbers. How can you use addition, subtraction, multiplication, division, and create non-real numbers? Pi is a real number. Yes, pi is on the number line. Dividing by 0 is a problem. So if I had the graph 1 over x, are there numbers I'm not allowed to use? 0, right? So that graph would have a domain of all real numbers except 0. Okay? How else can you ruin real numbers? What's the big way that we've studied over and over and over? Square rooting negatives. So what numbers am I not allowed to plug in there? Negative numbers. So the domain of that would be from 0 to infinity. So the only time your domain is going to be restricted in a function that's a written equation is if you divide by 0 or you square root or any even root of a negative number. Right? If I change this to fourth root, that still runs into problems at negative numbers. Okay? As long as it's a polynomial, the domain is always going to be all real numbers. So we'll use the real number symbol. What about the range? From negative 6.25 up to infinity. So remember, we write small number first, big number second. So my range is going to be y equals negative 6.25, comma, infinity. Is negative 6.25 actually part of the range? Yes. So it gets a bracket. Is infinity part of the range? No, it never is. Never included. Range are the y values. So everything below negative 6.25 doesn't exist. There is no graph down there. Okay, now pull out a colored pencil. Highlight increasing. Where is the graph going up? Now we have to decide, am I looking at x values or y values? And the answer is both. Okay? All 4 of these remaining attributes, increasing, decreasing, positive, and negative. The question is this. Which, don't ask. Don't ask. Wow, that was a Freudian slip. Which x values create y values that are blank? That's the question we're asking. Which x values, or if you are elevated in academics and intelligence, white x values create y values that are increasing? Which x's make the y's go up? Well, we're going to take our colored pencil, and this is the up piece. Does everybody see that is the only part of the graph going up? But wait a minute. Isn't this piece going up too? Right. We always travel from left to right. So, what is the interval there? Wait a minute. Which x values create y values that are increasing? Do we care? Does the increasing care how low the graph actually reaches? No. It just wants to know when does it happen. So from 1.5 to infinity. Is 1.5 actually aimed up? No. Is it aimed down? No. 1.5 is level. That is the only level spot on the whole graph. Okay. What about infinity? Is it included? No. Okay. So then we get a different color and we do decreasing. This is the decreasing portion. What is the smallest x value in the decreasing interval? Negative infinity. What is the biggest x in the decreasing interval? 1.5. So from negative infinity to 1.5 are either included. No. Okay. New color, positive. Which x values create y values that are positive? So we kind of have two pieces. This is positive and this is positive. So what is the smallest x on the left side? Negative infinity. Katie, are you all right? You confused? Oh, that's your normal face? Sorry. Okay. What? Yeah. Yeah. Oh, okay. Wasn't aimed at me. Okay. What is the biggest x in that left piece? Negative 1. Where did you get that? That's the root. Is it actually positive at negative 1? No, it's on the axis, so it... Okay. And then there's a second interval. Where does the second interval begin? From 4 until... Do we include either? Now, I'm going to introduce to you one thing that we didn't use last year. These are the symbols union and intersection. Okay, they showed up on the core test last year. Nobody expected them to be there. So we're going to use them now. So union is actually an or statement, and intersection is what we call an and statement. For instance, let's say that I was combining two groups. I can either combine them as a union or as an intersection, for instance. So let's say I have pizza. I'm going to give pizza to anybody who is a girl or a junior. That would be a union. Now, does that exclude anybody in this classroom? Me, basically. Oops, that was a bad idea. Are you a senior? Okay. So we don't get pizza. So if I did this, girl or, wait, it's 11th grade, right? Girl or 11th grade includes everybody but me and poor Jaden. Okay? But what if I did intersection? 11th. So I said I'm going to give pizza to anybody who is a girl and a junior. Who does that exclude? All the boys and Ellie. Right? She's a senior. So do you get the difference between union and intersection? Union, everybody comes to the party. Intersection, the only people who get to come are those that are in both groups at the same time. So for this, for positive, is this a union or is it an intersection? So it's saying, is the graph positive in the left side or the right side, or everything that's in the left and the right? well, I explained that wrong. So are there any numbers in the intersection? Is there anything in the left side that is also in the right side? So let's say that this was all girls and that was all 11th graders. Does anybody fall into both sets? Can you be a number between negative infinity and negative 1 and between 4 and infinity? No. So the intersection is actually the empty set. So this intersection has nothing in it. It's like saying, you get pizza if you're a junior boy and you're smart, right? That's like, it doesn't happen. So this is going to be union. So the answer is the union of those two intervals. It's either in the left side or it's in the right side because there's nothing in the intersection. If you were doing a Venn diagram, there would be nothing overlapping, right? Well, and that's a good point. So if you're talking about positive or negative, you'll never have intersection. It's always going to be union. Well, this is not why union and intersection were created. We're just using it. Yeah. Circled. No, it's okay. All right. What about negative? Where is the graph negative? From negative 1 to 4, and we don't include either. Yeah, you're not going to see intersection anytime soon, and hopefully I'll get to it someday. I was just showing you the union symbol because it might show up on the core test. And by the way, don't flag things on the core test. Not probably, I'm sure you did. Because they're expected in October or November. No, not yet. So, okay. So, you you have everything you need. Just put your pencil down for a second. Let's talk about a couple things. Where is that graph negative? Nowhere. Where is it positive? Everywhere. Okay. Where where is the green graph positive? So I could either do negative infinity to 2, union 2 to infinity, right? That's one way to talk about the positive. Or I could just say real numbers, x is not allowed to be 2. Yeah. So if you want to just keep everything except 1 or 2 or 3 points, you can do this. Yeah. But for instance, what if you had a graph that was like this? If you did the intervals, you'd say negative infinity to negative 3, negative 3 to negative 1, negative 1 to 1, and 1 to infinity. What a waste of time. So you just say x is not allowed to be negative 3, negative 1, and 1. And that throws everything in except those 3 points. Okay? This green marker and I do not get along. All right. Good luck. Test.